If you're not using an adhesive with a product that requires an adhesive, that you may not retain that sealant. So maybe 3 months, 4 months, 6 months into it, that material falls out. But even of more concern is that the sealant stays in the mouth, but you get micro leakage.
And one of the things that happens with the sealant is when it's in the tooth, it'll eventually kind of pull away from the tooth itself.
So you'll get a mechanical lock, but you won't get a bond or an absolute seal from bacteria getting underneath there.
And you get a bacterial colony and you have caries underneath the sealant and it just explodes and then you have a real problem. UltraSeal XG Hydro represents one of the most complex chemistries we've ever developed at Ultradent.
And it wasn't as easy as we might have thought. Initially, we thought this might be a year or two turnaround, and it ended up being 8 years.
When we tore apart the chemistry, we were looking at one particular monomer, and we had found that it was the monomer responsible for getting us the bonding that we were getting. But the problem with it, it was also too hydrophilic.
We absorb water like crazy. And why is that a problem? Because that material absorbs water. Well, when it absorbs water, it expands. So you've got it down into a pit and fissure. It expands, it's going to pop out. And then you've got that micro leakage problem all over again.
So we started looking at outside vendors. We started looking at outside companies that made this particular chemical. We couldn't find one that was good enough.
So we went in the lab, we got the support from Neil and Dr. Fisher to hire the experts, the chemical engineers, buy the reactors, and we started to develop our own monomers.
There is no chemistry that could have got there on its own from the outside world. We created this chemistry inside, truly molecularly synthesized these molecules to be what they are. There isn't a chemistry that we buy in that does this. There are chemistries that come close and that help us get there, but this chemistry is ours, uniquely ours and synthesized by our own chemists.
What's nice about the Hydro is that you're still doing the etch, but you're getting a one-step, seal and bond, and with kids that's super important because they're wiggling, there's a lot of saliva with kids, and so to get in and get out and make sure you've got something that's going to last is really important.
We always have to etch the tooth in some fashion to get the resin system to first make microscopic details with the etch that then the resin can go in and bind into. Now, if water happens to be in those microscopic details, a hydrophobic resin will simply just lay on top of this and be plucked away, will fall away in time. And so as we progressed inside the adhesive world, we saw efforts where we could take the chemistry itself that wanted to go into those spaces, even if there were water present in those spaces, and find itself literally, even with water present, being able to be pulled into those spaces.
You have this big window of opportunity. And you're still going to get great results for the adhesion of the product.
We did a lot of work with actual teeth and we applied it on the tooth and we cured it and we compared it to our competitors to see how we worked based on their results, and then we would section the teeth and analyze the margins just to make sure that this stuff was getting down into the deepest pits and fissures possible, because that's what's going to actually do the sealing. You don't want any of those bugs getting down there and causing more problems in the mouth of the patient.
The UltraSeal XG Hydro needed to be able to want to find the deepest spots of those and be able to integrate into that to make a monoblock system, to make the tooth structure, the hybrid layer, and the resin act as one, and they do at this point. But to get to that point where these things hung on at twice the strength of the UltraSeal XT Plus, well, that was pretty rewarding.
You know that every bit of that groove is now sealed.